Ever wondered how safe your information is when you're browsing the internet? The World Wide Web is a vast and complex place teeming with information and, unfortunately, potential threats. Every day, we share sensitive data online, from banking details to personal messages, and each piece of information we send is at risk of being intercepted or tampered with. That's where internet security comes in. Internet security is like a digital lockbox protecting your data from prying eyes. It's a broad term that encompasses many aspects, but one key player in this field is Transport Layer Security, or TLS. TLS is a cryptographic protocol, a kind of mathematical code designed to provide security at the transport layer. This is the layer where your data is transmitted across the internet, so it's crucial to have robust protection in place. That's where Transport Layer Security, or TLS, comes into play. It's like a superhero of internet security. So, how does TLS protect your data? One word: encryption. Encryption is essentially the process of scrambling information into an unreadable format, a secret code, if you will, that can only be deciphered by someone who holds the key. This ensures that any intercepted data is meaningless to the eavesdropper, keeping your sensitive information safe from prying eyes. Now, TLS employs not one, but two types of encryption: symmetric and public key encryption. Let's break it down. Symmetric encryption is like a secure lockbox. The same key is used to lock and unlock the box, or in our case, encrypt and decrypt the data. While this method is fast and efficient, there's one drawback. The key must be securely shared between the communicating parties, which can be tricky over the internet. Here's where public key encryption comes to the rescue. Imagine a mailbox with a slot that anyone can drop a letter into, but only the owner has a key to open it. In this scenario, the mailbox is the public key, open to everyone for encrypting data. The private key, however, is kept secret by the owner for decrypting the received data. This method, though secure, is slower and requires more computational power. So how does TLS use these two types of encryption? Well, it ingeniously combines them to get the best of both worlds. It uses public key encryption to securely share a symmetric key between the communicating parties. Once that's done, it switches to the faster symmetric encryption for the rest of the session. This process, known as a TLS handshake, ensures that your private data remains private. But remember, encryption is just one piece of the puzzle. There are other mechanisms at work in TLS, ensuring your data's authenticity, integrity, and security. And while it may seem complex, it all takes place behind the scenes, making your internet experience smoother and safer. So, thanks to encryption, your data is transformed into an unreadable format until it reaches its destination. And that, my friends, is how TLS uses encryption to protect your data. Now you may ask, how compatible is TLS? The answer is very. Transport Layer Security, or TLS, is like the universal translator of the internet world. It's designed to work seamlessly with a vast array of web browsers, from the ubiquitous Google Chrome and Apple's Safari to Mozilla Firefox and even Microsoft Internet Explorer. But the interoperability of TLS doesn't stop there. It's also built to function smoothly across varied operating systems. Whether you're a Windows enthusiast or a macOS aficionado, a Linux loyalist or an Android user, TLS is there, working unobtrusively in the background to secure your online communications. And for those of you who like to peek behind the curtain, you'll find that TLS is not picky when it comes to web servers either. Apache, Nginx, Microsoft's iOS, it plays well with all of them. Now, let's move on to another significant aspect of TLS, its flexibility, particularly in terms of its operations for authentication mechanisms, encryption algorithms, and hashing algorithms. You see, when it comes to the internet, one size definitely does not fit all. Different applications require different levels of security, and the genius of TLS lies in its ability to adapt to these varying needs. For instance, When it comes to authentication mechanisms, TLS can employ everything from simple, password-based methods to more complex protocols that involve digital signatures and certificates. When we talk about encryption algorithms, TLS again shows its versatility by supporting a range of symmetric and asymmetric encryption techniques, from the widely used AES to the powerful RSA. And when it comes to ensuring the integrity of data, TLS employs various hashing algorithms like SHA-256 to make sure that the data you send is the data that's received untampered and unchanged. In the vast and varied landscape of the internet, TLS stands as a beacon of compatibility and flexibility. It's like the Swiss Army knife of internet security, ready to adapt to the needs of different applications and platforms. So, whether you're using Internet Explorer or Chrome, on Windows or macOS, TLS has got you covered. Now, how can you be sure you're connecting to the right server? This question leads us to one of the pivotal features of Transport Layer Security, or TLS, known as authentication. When you're connecting to a server, whether it's to make an online purchase or to check your emails, you need to be certain that the server you're connecting to is the legitimate server and not a malicious imposter. This is where TLS steps in. It uses a process called digital certificate authentication. In this process, a server presents a digital certificate, which is a form of digital ID, to the client. This certificate is signed by a trusted third party known as a certificate authority, or CA. The client then verifies the signature on the certificate, ensuring that it is legitimate and has not been tampered with. But wait, there's more to it. What if the data being transmitted between the client and the server gets tampered with during transmission? This is where another feature of TLS comes in: data integrity. Data integrity ensures that the data sent by the client to the server or vice versa remains unchanged during transmission. It's like sending a sealed letter through the mail. The seal ensures that nobody has tampered with the contents of the letter while it was in transit. In a similar vein, TLS uses a method called hashing to ensure data integrity. When data is sent, a hash function is used to create a unique hash value for that data. Upon receiving the data, the same hash function is used to generate a hash value. If the received hash value matches the sent hash value, it confirms that the data has not been tampered with during transmission. In this way, TLS not only ensures that you're connecting to the right server, but also that your data remains intact during transmission. So, whether you're sending an important email or making an online purchase, you can trust in the security provided by TLS. With TLS, you can confidently connect to servers and trust that your data remains intact. Sounds complicated? Well, the beauty of TLS is that you, as a user, don't need to worry about it. Think about it like this: when you drive your car, you don't need to understand the complex inner workings of the engine. You just turn the key and off you go. The same principle applies to transport layer security. Most applications implement TLS beneath the application layer, which is like a hidden engine running beneath the surface. This means that the intricate operations of TLS encryption, authentication, and integrity checks are all happening behind the scenes. Just like how you don't have to manually ignite the spark plugs in your car, you don't have to manually encrypt your data or authenticate connections when you're browsing the internet. The TLS protocol takes care of all these tasks for you. It's like having a silent, invisible security guard, diligently working to protect your data from prying eyes and cyber threats. This seamless integration of TLS beneath the application layer makes it incredibly easy to deploy and use. You don't need to be a cybersecurity whiz or a software engineer to benefit from the security that TLS provides. In fact, you're probably using TLS right now without even knowing it. Every time you see that little padlock symbol next to a website's URL, that's TLS in action. It's an assurance that your connection to that website is secure, that your data is being encrypted, and that you're communicating with the legitimate server and not some imposter. So while the technicalities of TLS may seem daunting, the actual deployment and use of this protocol is a breeze. It's designed to be user-friendly, to provide robust security without complicating your online experience. And the best part? You're not required to do anything. The applications you use have already implemented TLS for you. They're doing the heavy lifting so you can focus on what you need to do, whether it's online shopping, banking, or just surfing the web. So, while you're surfing the web, TLS is silently working in the background to keep your data safe. So, there you have it, the superhero of internet security, TLS, in a nutshell. We've delved into the incredible world of encryption, where TLS uses a combination of symmetric and public key encryption to secure your private data. Then, we touched on its impressive interoperability, working smoothly with most web browsers, operating systems, and web servers. We also explored the flexibility of its algorithms, offering a variety of options for authentication mechanisms, encryption algorithms, and hashing algorithms. We discussed how TLS enables the client to verify they're connected to the right server and how it ensures data integrity by checking that the data hasn't been tampered with. Lastly, we looked at how easy it is to deploy and use TLS as it operates invisibly beneath the application layer. Next time you're online, remember, TLS is working hard to ensure your internet security. Stay safe out there.